My name is Mr. Monzia, and I'll be covering the lesson on engineering drawing and design as envisaged by NEC. And this one is a lesson for Diploma Module 2, the Diploma in Electrical Engineering with the power option, electrical, electronics, and telecoms. This subject is applicable to all those three specializations. Now, earlier on, I think you had seen the syllabus content. So what I'm going to do today, I'm going to expound a little bit on the syllabus so that the books at the end of that syllabus content are given some reference books. And I think once I do the expounding, you'll be able to maybe locate other reference books that you can refer to. Now, this subject is divided into various sections. The first one is geometry. And in the geometry, we have got plane geometry and solid geometry. Now, these two are identical, or rather similar, to what you did in your first year engineering drawing. The only difference here will be that you'll be learning to do those drawings using a computer for the drawings. That means the orthographic projections, oblique projections, and the isometric projections, all those you must be able to draw them using a computer. That's only the major difference between the first year stuff and this one here in the second year. Now the second one we have is symbols and circuits. Now, in these ones here, the symbols we use them for communications. The symbols and circuits. The first subheading, sorry for that one, is electronics. And electrical symbols. Now, in electrical engineering, we normally use symbols for our communication. As you know, most of our diagrams, in the schematics and wiring diagrams, we don't draw them to scale. We normally use the symbols, and for the connections, we normally use straight lines. Now, for the diagrams to be understood nationally and universally, we need to have some standards. I think later on, there will be a short summary of the standards. We need standards. You know, in Kenya here, we have got KEBS, Kenya Bureau of Standards, which produces some standards. We have also got the British Standards Institution, which produces standards. Their standards were previously used in a lot of the Commonwealth countries, including East African countries. And of late, we have got the ISO, which is more or less universal to foster trade between all countries. So nowadays, most manufacturers, even learning institutions, they tend to go for the ISO standards so that what you are producing or what you are marketing can be used anywhere in other countries whereby ISO is available. Now, after the electronics and electrical symbols, we shall go for motor connections. And control circuits. Now, for much of our circuits and in the symbols, we shall be using the ISO symbols as well as the BSI symbols. But for our motor connection and control circuits, we'll be relying more on the IEE regulations, which I'm sure most of you have come across them in your first year in Introduction to Engineering. IEE regulations normally sometimes referred to as the Bible of electrical engineering. Anything you do in electrical engineering, they give some recommendations, which means if you follow the advice, what you do is assumed to be safe. So they are recommendations, they are not actually mandatory. The motor connections will be mainly dealing with three-phase motors. The single-phase DC motors, I think they are a bit simpler, and you did them in your first year. So this time we shall be doing the three-phase induction motors. Their connections and control circuits. Now, before we come to the motors, we need to understand how the power is generated and then supplied to our installation. Maybe these three-phase motors, you'll be finding them in industries. So we shall briefly discuss about power generation, transmission, distribution, and then briefly we shall talk about the substation, what we call the final substation. From the last substation, how is power connected to your industrial or commercial workshop? So after we deal with the final substation, final station, this is as far as the power is concerned, then we shall see how power is connected to our motors, and from there on you can go for the motor connections circuits. Now the theory about the motors, how they operate, how they are wound, that one will be covered in the electrical circuit analysis. Another subject is usually combined with engineering, building and design for the NEC examination. And then you have got lighting circuits. Now that is electronics, symbols and circuits, motors. The next one is lighting circuits. Now the lighting circuits, most of them will be finding them in the industrial installations as well as domestic installations. So before we deal with this one here, we shall also look at the power supply to a domestic installation. Again, how is it connected to the final substation and then supplied to your connection. And then here we'll talk about the consumer control unit. And then from here, we shall talk about the controls of the lighting. And then you have got various types of lights. You have got the incandescent. You have also got the discharge lamps. We shall deal with them. And again, here we shall also be relying on the IE regulations for our circuits. And of course here, this control of lighting circuits, we have to assemble the circuits. Now this particular module is actually written as practice. So here we have to assemble the circuits so that apart from the theory, you become a hands-on man, and then man or lady, and then we shall be dealing with socket outlets. Again, we shall refer to the regulations when you are connecting socket outlets, what you need to do. And then again here we'll also assemble, teach you how to assemble the circuits. And then in the domestic scenarios, we have got components, we use power supplies. That means most electronic equipment, they use DC current, so you have to look at power supplies. That means the AC has to be converted to DC. So power supplies, and in the module 2 level, whenever a question of power supplies arises, you should know that we are dealing with regulated power supplies, including dual power supplies as well. Now these are, again, circuits you should be able to assemble. And then the last bit on this subtopic, I've got schematic circuits. Now, the lighting circuits, we have schematic circuits as well, and we also have wiring circuits for the lighting circuits. The schematics in electronics, we have also got schematic circuits. That means this is why we shall be using the symbols to draw circuits. Now, the circuits, schematic circuits, you're supposed to know or be able to assemble are the ones you also be covering in the other subjects. That means in your digital or analog electronics, there's some circuits you come across. In PLC, there are also some circuits you come across. Now, those circuits in this paper, you may be asked to reproduce them. So it's good, the symbols you learn in the other subjects, which are also part of BS or ISO symbols, you should be able to produce them in this paper come the next examination time. Now, the third topic is one on design. The third one is design. Now, the circuits you'll be doing them, you should be able to come up with a design. In the lighting circuits, which are domestic, normally when you have a client, the client will describe to you what he wants, and then it's for you to come up with a circuit. Similarly, for the electronic circuits, what you have, maybe you need to assemble it. So in the design bit, we shall be doing what we call the principles of PCB design. Now, in your first year, electronics practicals, the ones you did, we are using the strip board. This is the board with holes in it. And then you have to think a way of how to connect your circuits. Now, after your Diploma 2 level, any circuits you construct on electronics, you're supposed to design it using a PCB. So principles of PCB design, we'll go through them here. And then we've also got electronic circuits. Now, before you do your PCB design, well, this is the next topic here, which is number 4, which will be referred to as electronic circuits. This one will involve manual fabrication of PCB. In number 3, we shall do the principles. Now, before you design your PCB, these circuits, you need to assemble them on a breadboard. In your design bit, you'll be using what you call a breadboard. Later on, we'll be seeing it when we start going through the lessons. In some other books, they refer to as a project board, whereby you can assemble the circuits, see whether it will work or not. The good thing with the breadboard is that there is no soldering involved. You simply insert your components the way your circuit is, and then once you are sure it can work, then you apply your principles and you can fabricate your PCB. Of course, we know the PCBs, they can be one-sided, double-sided, and nowadays you have got 3 sides. One copper clad on one side, the other side, and another one in the middle of the board. Manual fabrication of the PCB. Again, this one here, we shall pick on a circuit and assemble it. I think also you can also come up with your own circuit. Once I go through my process here, you can practice yours at home. Again, this one will show you how it is done, and then you can also practice it on your own. And of course, with the manual fabrications, you'll be things like the PCB layout, and they go through the whole process manually. Now, the 5th and last topic is one of computer-aided and computer aided, computer aided electronic drafting. Now, under this subtopic here, we shall do introduction to computer aided design, referred to as CAD. Now, before we do this one here, it will be assumed that in your first year, you have done those computer packages like which are involved in Windows, MS Word, Excel, database, and the like, so that you take a little bit of short of time on this one here. So in the computer-aided design, we shall redraw the first topic whereby you have the plane and solid geometry. Here, you should be able to produce all those diagrams using the computer. And then we shall also talk about drafting softwares. The kind of softwares which are used. And then here we shall be doing our electronic circuits simulation. In other words, today we have got circuits, we have got softwares whereby the electronic circuits we design here, which we fabricate here, you can also draw them in the computer and they can become active, and maybe you can even measure potential. In the software itself, we have got things like oscilloscopes, measuring instruments, and the like, so you can activate the circuits. So here we use the breadboard during our design. Nowadays, you have got the softwares whereby the whole design can also be done in the computer, whereby you can select your components, assemble the circuits, and then it can become alive, and you can do measurements the normal way we do it manually. So the computer nowadays has made our work easier, only that it's creating a lot of unemployment. So briefly, that is an expansion of our syllabus. Now, the other thing I want to add up is when it comes to the examination. Now, this engineering drawing and design is combined with circuit analysis. So in your exam, of course, here you're referring to the neck. Everything we are doing is for the neck syllabus. In the exam, you've got engineering drawing is combined with electrical, circuit analysis. Circuit analysis, where you do much theory of these other things we are doing here. Remember, in the drawing, is simply drawing and doing the practical aspect of it. Now, in the engineering drawing, we'll be setting 3 questions. For the 3 questions, and you answer any 2. The circuit analysis, there will be 5 questions. You answer any 3. Now, one thing I like stressing to students is that sometimes these sections are interchanged. In one paper, of late, the majority of cases, circuit analysis usually section A, engineering drawing, section B. But I've seen some papers whereby engineering drawing is in section A, circuit analysis in section B. So don't always assume to start with circuit analysis and then engineering drawing. So that's how your exam will be set. Now, one thing I keep stressing to students is that what we go through here, more or less, in our case, there is a bit of practicals involved. It is essential you become a hands-on fellow. Once you finish this course, you'll get a paper, certificate, a diploma certificate when you finish Module 3, and that will simply mean you are only qualifiable for whatever job it is that you'll be applying, but not necessarily qualified. There's a big difference between the two. Normally, for you to be qualified, you need the theory as well as the practical. That's what the country needs at the moment, hands-on people. Now, what we cover in our lessons, the ones we shall be going through, is pertaining to the NEC syllabus. Now, once you go for attachments, you may be going to companies like the SGR, where they have got Chinese. Now, Chinese, they have got their own symbols of doing things. Much of the drawings, when I came across them, I could not be able to interpret them. But they also follow the ISO. So what we give here will be the basics. Once you get to site, irrespective of whatever company or the equipment comes from, the basics will remain the same, maybe with some additional modifications. And especially when it comes to the motor circuits, we'll give you the basics. When you go for attachment in industry, you find the circuits are a bit more, there's some more additional control in the circuitry. For example, when you are designing a circuit for motor to go forward and reverse, we shall do the forward and reverse circuits. In industry, you'll find that they have to make sure that the motor is stopped before you can change direction, an additional control facility. We have also, in the case of the three-phase motors, we have to test that the three phases are present. Otherwise, in case of one phase failing, the motor should be cut off. And then in the industries, they also detect the voltage levels. The voltage levels go below a particular point, and then the motor should be able to cut off. The beauty with the modular system is that it has got that attachment bit, and that's where you marry the theory we do here and the practical at sites. And I think briefly that expounds the syllabus. Now, in the syllabus I had given some reference books. Now, those books, they are not exhaustible. But now, since you are aware of what it entails, you can also look for other books. Any book on electrical technology, electrical engineering technology, can be of much help in the stuff that you'll be doing. Generally, I would recommend you buying the books, but reading them, making your notes, or getting the relevant chapters should be okay with you. Unless, of course, you go into consultancy, in which case you'll be needing the books to be with you. Now, the lessons is a practical, so we should be ready for hands-on.